Alright, welcome back to Mr. B's math class. Today we're looking at 9.3 linear relationships. Our student outcomes for today are I can graph from a formula, I can graph from an equation using integers, and I can solve problems using the graph of a linear relation. So let's take a look and see what that all means. Well, to start, we're going to look at graphing from a linear formula. So we know from the previous lessons that linear relationship means that we are going to find a pattern on the table of values and on the graph, and all the points are going to lie in a straight line. So we're going to apply that knowledge. When it says linear, we know right away that this relationship here is linear already. So we know we're going to find a straight line in the end. So our example 1 says a long distance telephone plan can be represented as C equals 6t, where C is the cost in cents and t is the time in minutes. So they would like us here to complete the graph and the table of values. So let's start with what we're going to work out here. So when we look right away here, we've got our little formula there. So if C is equal to 6t, what that's saying is that the cost right here is equal to 6 times whatever that is. So we don't know what this is, so we'll put C for this one, but equals 6, and then when we look here, our t value is 1. So 6 times 1 is 6. So that means our first C value is 6. Our next one here, we have C equals 6, but now our t value has changed in this row here, and it's now 2. Now I apologize, my arrow got in the way there, but 6 times 2 is, well, 12. So that means our next C value is 12. And we can keep doing this again. So we have for our third row, C equals 6 times, well, our new value here is 3. So 6 times 3 is 18. And I think you can already see the pattern forming here, but we'll do one last one just in case. So we'll use our formula again. C equals 6. Our t value is now 4 minutes, so 4. 6 times 4 is 24, and we've got our final value. Now you probably could have finished this question before the last one there, because you could see the pattern emerging. C is going up by 6 every time. It went from 6 to 12 to 18 to 24. So if there were more rows down the ways, you could have probably figured out the next couple in the series. But now let's take a look here. We got one part of it done. Now it wants us to graph it. So that's pretty easy. Now unfortunately I didn't have any graph paper here with me, so bear with me on my sloppy looking graph, but we'll now plot our points from our table onto a graph. So our t value is our x value, because we know that x and y, x is always first in the table of values, but x is always at the bottom here. So we'll take a look at that. Well, our first t value is 1, our next t value is 2, our third is 3, and fourth is 4. On our y-axis, so our c, our cost, we can see that it's going up by 6, 12, 18, 24. Now, I could just write that, but it's easier to be consistent with what we're going up by, which we would be, but I'm going to just make it a little bit easier. So I'm going to go up by 5, 10, 15, 20, and 25. Just consistent values on the side that I might use in future examples as well. Now we've got that, the last thing here we have to do is just plot our points. So we look at our t value at 1, and we've got our next value is 6. So 1 and 6 would be right just above the 5 there. Our 2 value for t is 12, so we're going to move up and just go just above the 10 there. Our 3 value is 18, so we're going to look at just above 15 there. And our 4 value is 24, so that'll be just up and just below that 25. Now we can already see that right from this, we have a straight line. Now, granted, this actually probably should be right there, just a little bit higher, but again, I'm just freehanding it here in the computer. But yes, so we know we got a linear relation because we have patterns on our table of values, and we've got a straight line, so check. Now the last question they might ask you on your assignment, it might say, is it reasonable to have points between the ones in the graph? Now what that's saying is, would it be reasonable to actually have had something here for, let's say, 1.5? Would that have been reasonable? Would it be reasonable to show information for 2.5, 3.5, whatever it would be? And the answer would be, well, yeah, because you can actually have something go on for 1.5 minutes, right? You're not stuck with paying just for 1 minute, 2 minute, 3 minute, 4 minute. You might be on the phone for a minute and a half. And that would tell you right here, well, if you're on the phone for a minute and a half, it might be a little bit more than 6, but obviously less than 12. So it would be right in between. So yes. So if that happens on your assignment, it's just asking if it'd be reasonable. Some examples, wouldn't make sense to show 1.5 or 2.5. For example, if they were looking at the cost per person to go to a movie, 1.5 people aren't going to pay to go to a movie. They're going to have to sell it in quantities of per person. Let's take a look at the next example. All right, so example 2. I'm going to have you guys try this one. So the question says the amount of water used by a sprinkler can be represented as V equals 10T, where V is the volume of water in liters and T is the time in minutes. I'd like you to give it a shot on your own here, and then just unpause it when you're ready to see the solution. Okay, so for this one here, what we're looking at again is our little formula for each row. So volume equals 10 times T. Well, this one's already done for us, actually. That's nice. So our volume here, we don't know, but it's 10 times T. Well, in the first row, it's 0. Well, 10 times 0 equals 0. So we've got that one done for us already. Next, volume equals, well, 10 times, our T value next is 1. So 10 times 1 is 10. So we can fill that in as 10. Our next row here, volume equals 10 times T. Well, our T value now is 2. So that equals 20. Volume equals 10 times our next T value in minutes is 3. 30. And I think you can see the pattern emerging here. It's going up by 10 each time. Without even having to do the final example here, you just know that it's going to be 40 to save yourself some time. So once you see a pattern emerge, just double check, and you should be able to fill in the rest of the table of values to save yourself some time on that work. Now, the last part here is just taking a look and transferring this to the graph. So once again, I don't have a fancy graph, but we have this little freehand one I drew. So I'll just input these marks here. So we have our 0. Our T values go up by 1, 2, 3, 4, and just for good measure, we'll put 5 there. And our Y values, or volume, are going up by 10. So that's pretty easy for us. We could just do 10, 20, 30, 40, and 50. And the last thing is to plot them. Well, our first plot point is 0 and 0, so I can do a circle right there. Our next plot point is 1 and 10, so I can go from the 1 right to the 10 there. Our next plot point is 2 and 20, so I can go right to 2 and 20, freehand here a little bit. Our next plot point is 3 and 30, pretty easy so far, and 4 and 40. Now again, it won't be perfectly straight, but as you can see, it's definitely linear relation because we had our pattern in our table of values, and we have our straight line. Now again, the question could be asked, would it be reasonable to show values for, in between, so 1.5? And here again, the answer would be yes in this question because we're looking at units of water, and water isn't only sold, or used, in 10 volume increments, in 10 liters, right? You could have 11, 12 liters, 14, 25 liters. So yeah, it would make sense to actually see how many actual liters are being used in time limits. So that would make sense in this question. Let's take a look at our next one. So evaluating the equation using the given value. This is just some basic work here without having to get too deep into graphing, which is good. So in this one here, we're actually doing what we just did before, but adding one step further. So what they're saying is they'd like to know what y equals when we have an equation, or not, where I have an expression, of 5x equals 3. So all we do for this is we just substitute this in as the x, because it's saying 5 times x minus 3. And they're telling you that, hey, x is 6. So when you see this, the first thing you have to do is just substitute. So we have y equals 5 minus 3. Well, x equals 6. We just put the 6 in there. Now, because it's stuck to it, that means it's saying multiplied. So we'd have y equals 5 times 6. 5 times 6 is 30, minus 3. And then we just keep working our way down. Y equals 30 minus 3. Y is 27. So what that's saying is that when x is 6, y is 27. They can tell you that right now. So just summarize that again. When you have a question like this, all you have to do is solve a question like basic math by simply substituting in your x value where it belongs in the question and solving it. I know that kind of might seem confusing at first, but let's take a look at another example to go through it again. So this question says y equals negative 5x. So what does y equal when we have negative 5x? When x value is negative 2. So if you want, pause it right now, give it a try, and unpause it when you're ready to go. And if you're still confused, no worries, we'll just keep going right from here. So once again, the only thing we have to do for this question actually is quite simply just substitute this in for the x value in the question, because it says x is minus 2. If that's true, this question looks like this now. Y equals minus 5 multiplied by minus 2, because we've put this negative 2 in for the x value where it belongs. And all we have to do now is multiply, and that's it. So y equals, now you notice right away we do have integers. So we have our sign rule. We do have two negatives. We know that a negative times a negative equals a positive because it's the same sign. So right away we're going to have positive because negative and a negative. And then 5 times 2 is 10. And that's it. So for these, all you're having to do is simply just substitute the variable in for what they're telling you and solve. For most of the questions you're going to deal with today and for the near future, you're mostly going to be solving for y, and they'll give you the x value for the most part. They may throw 1 in or 2 in later on, but for right now it'll always be the x value will be given to you so you can solve it from there. All right, let's take. Okay, so now we're going to kind of take what we've learned before in both of those and just kind of combine them together. So now we're looking at completing the table of values using an equation. Well, in this one here, they've kind of given you a lot of information that you may not get in the future, but right now they've kind of given us our equation here. They have told us y equals 4 minus x. Now, in this question, it's not just one simple y value you're looking for. You're actually looking for each of these y values. But good for us, we know all the x values already. So all we have to do is just apply that same thing we just did with substitution in for each of our x values here, 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 and here. So what I mean by that is, more or less, our little formula here is going to stay the same. Y equals 4 minus x, okay? Except we know what the x value is in this row because the x value here is 0. So all we have to do is go y equals 4 minus 0, which equals 4 minus 0 is 4. So the y value is 4. We do this again for this next one. So y equals 4 minus x. Oh, that's a terrible x. Which then gives us 4 minus x is 4 minus 1, which gives us 3. There's our 3 value. We do it again for the next row. Y equals 4 minus, oops, my bad. That's not what I wanted to do. I can't erase here. 4 minus x, which then gives us 4 minus, and we can see right here that value is 2. 4 minus 2 is 2. We do that again here and substitute in. Y equals 4 minus x. 4 minus, and we got a 3 here. So we have 4 minus 3 is 1. And I think you can kind of see the formula taking place here in the pattern. 4, 3, 2, 1. They're going down by 1 each time. So we know the answer should be 0, but we'll just double check. Y equals 4 minus x, which when we substitute that in, is 4 minus 4, which equals 0, check. So again, when you see these, all you have to do is substitute in all of the values here for each of the x, whereas the last question, it gave you just one x value. Here they're giving you the entire table to solve. Okay, so let's try this again on the next page here. So I want you to try this one. So same idea. It says complete the table of values for each using x is equal to negative 1, 0, 1, 2, 3, and 4. And your little formula here is y equals negative 3x plus 4. So give that a shot and then unpause it when you're ready. If you're not sure, just stick on the video here and we'll finish together. Okay, so for these, the first thing we have to do is just take a look at our x values. They're telling us where they have to go. We know what our x values are. All we have to do first is just fill them in on the table of values here. So our first x value is -1, then it's 0, then it's 1, 2, 3, and 4. We got half the question done now, that easily already. And now the question is no different than the one before this. All we have to do now is just substitute in each of our x values into our wonderful formula up top. So if we look here on the first row here, y equals -3. Our x value in this situation, as we know, is -1. So -1 plus 4. If we were to solve that, -3 and -1, we know that's going to equal +3 because the negative and a negative equal positive, plus 4, which gives us an answer of 7. So we have a y value of 7 when x is -1. We have to do this for each of the rows together. So again, we look at it, and y equals -3 times by, well, our x value, and this one is actually 0, plus 4. Well, 3 times 0 is 0, plus 4 is just 4, because 0 plus 4 is just 4. Do it again for the next row. Y equals -3 times, and this x value is 1, plus 4 equals, well, our -3 times 1 is -3 plus 4. Now we know from our unit 8 on integers that if we have 3 negatives and 4 positives, we're simply left with just 1. So we have 1 now. And you can kind of start to see the pattern emerge, but just in case, we're going to try this again. Y equals -3 multiplied by x, which we can see is 2, plus 4 equals, well, -3 times 2 is -6 plus 4. So -6 plus 4, we know we have 6 negatives and 4 positives. That leaves us with -2. And we keep going this way for another one. Y equals -3 times, well, our x value is 3 here, plus 4. -3 times 3, a negative and a positive still equal a negative, so we have -9 plus 4. We know we have negatives and 4 positives, leaves us with a -5. And we could look at this graph right now and take a look at the the table, and see our pattern emerged. We can look at it and see that it's going down by 3 each time, or -3. 7 minus 3 is 4, 4 minus 3 is 1. 1 subtract a -3 would be -2. -2 minus -3, -5. We know the answer is most likely going to be -8, but let's just double check our work. So we've got our y value equals -3 times 4 plus 4. -3 times +4, we know it's different signs, so it's going to be -12. Plus 4, we have a -12 and a +4, leaves us with a -8. Check. We have got it.